Hello, my name's Amelia and I studied Molecular Biomedical Engineering at Imperial College London. I actually just graduated yesterday, and for my fourth year I was working in the lab, and it was quite an experience because you watch like TV shows and all that sort of thing and you see them in the labs and that sort of thing, especially in those superhero movies, and you're just like, oh, that's like, it's so amazing, it's so glamorous and that sort of thing, but they don't show the behind the scenes. And working in a lab is really amazing because you get to solve problems, like you get to look deeper into certain things. Like I was looking at a molecule that can accelerate wound healing. So, and I was looking at some mouse samples, some mouse skin samples, and just like looking at different components and how that drug really works and all that sort of thing. So it was really interesting because I was working on something novel and new. But there was other sides of it that I really didn't like, because when you work in a lab, you have to be ready for your experiments to fail. You have to be ready for something to break, to get tired of looking at a computer screen, analyzing all your data, because I was using a confocal microscope. It's kind of like, it's a huge piece of tech that takes pictures of immunofluorescent staining. And I had a lot of slides. I had like 96 slides, and looking at each slide takes you about 25 to 30 minutes to look at, and it was a lot. So by the end of the day, you're tired. Like I would go in at like maybe 10 a.m, go into that room and then come out at like 6. So just sit there the whole day. You don't really want to move because you just want to get it done. Like you don't want to have to come back here tomorrow to bring out your slides again, defrost them, take them upstairs to the computer room and that sort of thing. But it's like that's the step you have to take in the process to get that much needed data, because after you've got those images, it's kind of like, oh, I've got a lot of pretty pictures, but what do I do with the pictures now? Then you have another software that you have to use to analyze all your pictures. And then it's a lot of pictures. Like each slide you take like maybe 5 or 6 pictures. And I had a lot of slides, so I had a lot of pictures, and then it's all over again. But then once you get those data points, those all important data points in science, like you can't do anything without a data point, and you've plotted all those graphs, those wonderful graphs, and you finally get to see what leads to what, how this specific thing causes that. It's like a whole new world opens up because you're finding a solution to a problem. All those hours of work finally there's like all those hours of work finally, they have a purpose, they have a meaning, because now you're finding a solution. And I remember when I was in the lab, well, in the computer room, taking pictures of one of my slides, and it was dirty. And so I got out some paper to like wipe it, and I broke the slide, and I was so gutted. I think I almost cried, and then I remembered that, okay, I have another slide that I can take a picture of, and then I can just pretend it's this slide. And I was just like, okay, Amelia, just calm down. It's okay. You don't, because the immunofluorescence, you have to stain the slide, and that staining process takes 2 days per slide. So I would try and do like 14 in bulk, and my supervisor said that she never does more than 6 at a time. And I tried to do that, but it was taking far too long, because remember I have 96 of those to do. So if I do 6 at a time, I'm going to be there forever. So I was doing 14 at a time, and I'll think to myself, what if you mix your antibodies wrong? What if this and this is wrong? What if you make a mistake, and that one mistake you made, you've ruined like 14, 20 slides? But those are the sort of like thoughts that you have to just push back and be like, no, let's just do this and get to the end of it. And yeah, that's the kind of stuff I love about research, because I don't know, there's that background where you have to put all the hours in, put all the work in, but when you finally get the data out of it and you're looking at that data and you're making all of these conclusions, because at first you're making assumptions and then you get to make conclusions at the end. That's what really matters, because with those conclusions you can actually start to say, okay, how can this help a person, how can this help a patient? Like with my project with the molecule that can accelerate wound healing, after I found out all this stuff about it, I could say maybe it can accelerate, maybe it can reduce scarring, maybe it can help people with burns and that sort of thing. Like, I think it's stressful, but the stress all mixes up at the end into happiness, because you're able to create something that can help others because you spend the time to look deeper into a subject. So I was using mouse tissue, mouse skin, that was sent over from a university in America, the University of Arkansas. And so they sent it over in kind of like a little block of gel, and they had frozen it. So I would defrost these. They didn't really take long to defrost because the chemical they used to freeze them was very volatile. And then after that, I would take them to a machine, and that machine would help me cut them into like little strips. And then I would have little slides, so there would be little rectangles of glass, and the pieces of skin would just stick to those rectangles of glass. And then I would put maybe like 3 pieces of skin on each glass, and then I'll take these these little glasses, the slides, and I would stain them with different antibodies in the lab, and that would take like 2 days. And then, like, after the staining process is done, I'll take them up to the confocal microscope, which is where I take all the images, and the microscope would be able to tell me whether or not my staining worked. And if the staining didn't work, then I'd have to just go back and stain some of the slides again, and maybe like change some of the concentrations of the antibodies and things like that to get really crisp images. So my advice to anybody who'd like to study molecular biomedical engineering is that you need to know quite a lot of chemistry, a bit of biology, not the whole of it, but mostly all the stuff about genetics and statistics, a lot of statistics, because you need it when you're analyzing all of that data.